Good afternoon everyone, I'm Mr. Ish. Thank you for joining me for this video. In this video, we're going to keep it interesting. We're looking here at inverse trigonometric derivatives and deriving them. We're not looking at examples solved out, but we're looking at the derivation schemes for what you see here before you. These four being the most important: arcsine, arccosine, arctangent, and arccotangent. And the derivatives are laid out for you. You can see the derivatives are right over here. What we go about in this video is to see how these derivatives are derived, and it's a useful exercise. Remember, in calculus or in subjects similar to calculus, when going forward, it's always important and necessary to take a few steps back every now and then to revise what you know, because as you keep proceeding forward, you have to make sure not to forget what you have learned. So the fun begins here with the derivation of the inverse sine or the arcsine derivative. You have an expression y equals arcsine x, which is also equal to inverse sine x. They're synonymous. The derivation procedure for the derivative begins with you rewriting this as sine y is equal to x, because you've just taken this onto the other side. This expression over here is easy to handle because you can do implicit differentiation of it. You'll do d over dy sine y dy over dx is equal to the derivative of this x, which is something familiar. You know how to do this. What's the derivative of sine y? It's cosine y. And then dy over dx, which is what you're always solving for, is equal to 1. You take cosine y on the other side, dy over dx is equal to 1 over cosine y. You have that trigonometric identity, sine square y plus cosine square y equals 1. You can solve for cosine y. Cosine y is equal to 1 minus sine square y, all within a root. You've solved for that. You substitute all of that right in place of here. You get 1 over root 1 minus sine square y. But this can be easily handled and converted by you looking at this. If sine y is equal to x, it makes sense that sine square y is equal to x squared. You can substitute the sine square y by x squared. You substitute right over here, you get 1 over root 1 minus x squared. And this right here is the derivative of arcsine x. But the other way you can look at this is by this expression right over here. You've come up to this expression right over here. You have 1 over cosine y. But what was y originally equal to? Y was originally equal to your expression at the very beginning. You can look at it as that way. Cosine of this y, which was arc sine x over 1. Now you know you can create a triangle out of this, and that triangle can take you very well to the answer you're looking for, that is the derivative. If you map out a triangle, a right triangle with a theta, and you use this definition arc sine x over 1, sine x over 1, this missing side must be 1 minus x squared within a root. Then cosine of this angle theta must be adjacent or hypotenuse 1 over root 1 minus x squared, which again is the derivative of arc sine x or inverse sine x, and that's what we were looking for all along. Now we should be able to breeze through the next three derivatives quite easily. We're going to find the derivative next of arc cosine x. The procedure will start like this. You're bringing cosine onto the other side of the equal sign. Cosine y is equal to x. You can do the implicit differentiation of this, and you know how to do that. D over dy cosine y dy over dx is equal to the derivative of this x. Easy stuff over here. What's the derivative of cosine y? Well, we know it happens to be minus sine y, and then dy over dx. You're always solving for dy over dx in these instances is equal to 1. dy over dx is equal to minus 1 over sine y. Looking right here at this equation, you can solve for sine y. Sine y is equal to square root of 1 minus cosine square y. You can resubstitute that in here. You get 1 minus cosine square y. Looking right over here, if cosine y is equal to x, cosine square y is equal to x squared, you can say minus 1 over root 1 minus x squared. But this is just one way of looking at it. The other way of looking at it is just looking at everything right here with regards to this initial expression. You can do minus 1 over sine y. What was y equal to right here? This y. You have sine, and y here was equal to arc cosine x. Arc cosine x. But it's an x over 1. Draw a triangle over here with regards to the definition you see over here. With regards to theta, cosine is x over 1. Then this missing side must be 1 minus x squared root. And then when you're doing the sine of this theta, you're doing minus 1 over the sign of that theta is 1 minus x squared root, and this gives you the definition you wanted, minus 1 over root 1 minus x squared minus 1 over root 1 minus x squared being the derivative of arc cosine x, and it's done. Let's do a similar procedure here to determine the derivative of arctangent or inverse tan x. Not too hard. Bring the tan on the other side. You get tan y is equal to x. This is an expression for which you can easily do implicit differentiation. You can do over here, you'll have d over dy, tan y dy over dx is equal to the derivative of this x. You know the derivative of tan y will be secant square y, and then dy over dx is equal to 1. dy over dx is equal to 1 over secant square y. Look over here, these could be x's, these can be y's. You know secant square y or secant square x is equal to tan square x plus 1 or tan square y plus 1. You can think of this as 1 over tan square y plus 1. Look right here, if tan y is equal to x, then tan square y must equal to x squared. You can easily substitute this tan square y for x squared. You get 1 over x squared plus 1. But again, this is just one way of looking at this derivation of this derivative. The other way is by focusing right here at this part right here. You have 1 over secant square y. But what was y originally? Y was equal to arctan x. You can rewrite this as 1 over secant square arc tan x, but it's x over 1 technically. Map out a triangle. Tan definition is always opposite over adjacent, then this becomes x squared plus 1 or 1 plus x squared. Order does not matter when you're adding. You have to look at everything here now with regards to secant definition. With regards to the secant square of this theta, what will it be? Secant of this theta will be x squared plus 1 root, but then you have the secant square, you gotta bring in that square. When you open up this, you get 1 over x squared plus 1, and you've gotten your derivative, inverse trigonometric derivative derived for this arctangent, and it's done. Both of these are good. Now for the last part of this video, we have to find the derivative of this arccotangent. It's not hard. You use a similar procedure, rewrite this equation. You rewrite it as taking the inverse cotan on the other side. You get cotan of y is equal to x. You can do implicit differentiation of this expression right here. You'll have d over dy cotan y. Then dy over dx is equal to the derivative of this x. When you do the derivative of cotan y, you know what that is. Think back to your trigonometric derivatives. You'll have dy over dx, you'll have minus cosecant square y is equal to 1. And then dy over dx, you're solving for that, is equal to minus 1. You take this on the other side, you have cosecant square y. So you end up over here, and it's not hard to take this to the next level. You already have this expression over here. Cosecant square y is equal to cotan square y plus 1. You can substitute that for right here. You have minus 1 over cotan square y plus 1. But we gotta do something with this. What do? You look right over here. If cotan y is equal to x, then cotan square y must equal to x squared. This x squared can substitute for that cotan square. You get minus 1 over x squared plus 1, which is your derivative, but we can do this by another way. When you look right over here at this expression, minus 1 over cosecant square y. But y was originally equal to arc cotan x, which is x over 1. And you can see that right over here. Develop a triangle from here. In terms of theta, cotan is always adjacent or opposite, and then this becomes 1 plus x squared in the root. You're doing the cosecant of this theta, and you can do that very easily because you know the definition of cosecant. It's going to be hypotenuse over opposite, and you plug that in. So the cosecant of this angle theta is going to give you root 1 plus x squared over here, but there's a cosecant square, so you gotta square this over here. You get a minus 1 over 1 plus x squared or minus 1 over x squared plus 1. Order does not matter, but these are both equivalent and they're both right. So in this video, we've looked at the inverse trigonometric derivatives derived for arcsine, arccosine, arctangent, and arccotangent, the 4 of the most important inverse trigonometrics that you need to know of in differential calculus. So these are the 4 you need to know of, and they've been laid out here in front of you. And that would be it for this video. Thank you for watching. Have a nice day.